taking the world, you'll see. They'll be calling me, calling me. They'll be calling me royalty. Best to give me loyalty, 'cause I'm taking the world, you'll see. They'll be calling me, calling me. They'll be calling me royalty.
Content Expert. In this video, we will be discussing equality within JavaScript, as well as type coercion. So there are two equality operators in JavaScript. So for example, we can console.log. This is the first equality operator that we have, and we can run this and you see, of course, we get true. But we can also say console.log 5 and then triple equal sign 5. And this will end up doing essentially the exact same thing in this instance. We get true for both options. So the question now becomes, what is the difference here? Well, this first one up here, 5 with double equal signs, so the double equal sign operator, is usually referred to as the loose equality operator, or sometimes just the equality operator, whereas the triple equal sign is referred to as strict equality. And strict equality means that we are comparing type and values, whereas with loose equality, we're only comparing values. So let me give you a more concrete example. Let's change the value of 5 to be a string. So now these have different types, and this is a string. And we can do the same thing down here. So we can change this to be a number and a string, but they have the same value. Both of these can be equated to being 5. And if we run this, The first one is true. Loose equality is only checking the value, and it says that these have the same value. They're both 5. And strict equality is false because it checks for the type and the value, and in this case, the types are different. On the left-hand side of the equality operator, we had a number, and on the right-hand side of the operator, we had a string, so it doesn't even need to look at the values. It just says these are of different types, therefore return false. Okay, so now the question you probably have is, how does it know that 5 and the string 5 have the same value? What does that? It's doing what we call an implicit type coercion. So it's converting one of the two types to another type, or sometimes it actually ends up converting both types. Most of the time, what it does is it tries to convert types into numbers. So for example, the string 5 was converted into the number 5, and the number 5 was already the number 5. So in this case, we ended up with two numbers of 5, so they ended up having the same value. We can actually do this type coercion manually as well, and we call this explicit type coercion. So for example, let's say we had the Boolean of false, and I wanted to convert this to a number. Well, we can call it with the number function and wrap it in this function. And what this is going to do is it's going to do just that. It's going to convert this Boolean of false into this type of number. So if we console.log this value out, what we're going to get is the number 0. However, if we change this to true, we get the number 1. So true equates to 1 and false equates to 0. So what that means is if we get rid of this and we say true double equals 1, it's going to be true because of the fact that true, when it is coerced to a number, becomes the number 1. However, if we did false here, we would get false. And if we did, in addition to this number function, we also have two more. So we have a Boolean function. So for example, we can convert the number 10 to a Boolean and we get true. We could convert the number 0 to a Boolean and we get false. And finally, we also have the string function. So this is going to sort of look the same in the output here, but it is converting this into a type of a string. And you can actually see this with the type of operator. So you can see the result here is a string versus if we did just type of 0, we would end up getting number because the type of just a number is number. Okay, so that's most of what there is to the rules of equality in JavaScript, but there is a little bit more that we should know that can help us understand what the result will be of some different equality operations we might do. And the first is around this value of NaN, or not a number. And this is the result you get when you try to do math with something that just can't result in a number. So for example, if I did console.log number of the string ABC, I'm going to just get this not a number value. And what's interesting about not a number is that it's not equal to anything. So for example, if we did console.log NaN double equals NaN, we're actually going to get false. So not a number, even just doing loose equality, is never equal to itself, and it's never equal to anything. But what this means is that anything that equates to not a number, especially when it is being coerced into a number, which is usually what the type coercion of double equals ends up doing, is going to be false no matter what. So for example, if we have the string ABC, this is not double equal to anything except for the string ABC because these have the same types, so no coercion is happening. But there's no other value that I can put here. So the string AB, it is false. The number 1, 2, 3, it is false. NaN, it is still false. No matter what we do, the string ABC double equals of anything except for the string ABC will be false because of the fact that when we coerce the string ABC into a number, it becomes NaN, and NaN is not equal to anything else, including itself. Okay, so next, what I want to look at is null and undefined. So a lot of times what you'll see is we have some variables. Let's say const x equals 5. And then what we need to do is later check if this variable is undefined or null. So maybe we want to say if x, and I'll just write some pseudocode here, is null or undefined, do something, right? And there's a couple ways we can do this. So I could say if x equals null or x equals undefined, and there's nothing wrong with this code, except for the fact that this isn't valid code, but there's nothing wrong here with this. This is perfectly valid, and it's what we do a lot of the time. But we can actually use the type coercion of JavaScript to our advantage here. So instead of this, what we could do is just do x double equals null. And the reason that this works is that when we have the double equals, so the loose equality operation, with null or undefined, the only values that null and undefined are equal to with double equals are each other. So let me show you what I mean by this. Let's get rid of this if statement for a moment, and we can also just get rid of this const statement as well. So let's do console.log. So let's say null double equals null. So this is going to be true because these values are the same. They have the same value. And null also equals undefined when using the loose equality operator. However, if we did the strict equality, this would loose equality, null does equal undefined. But what's nice here is that null doesn't equal anything else. So 0 is going to be false, a empty string will be false, an empty array, for instance, will be false. Anything except for null or undefined here will be false. So a lot of times what you will see is in that if statement. So instead of if x equals null or x equals undefined, most of the time what you'll end up seeing is just x equals null. And this essentially checks for null and undefined at the same time, which is just a nice little syntactic sugar. It can make our code a little bit easier to read, and we don't have to be thinking about undefined all of the time. The one caveat here is you need to make sure that you are using double equals and not triple equals, because if you use triple equals against null, it's not going to account for undefined as well. Okay, so now the last rule I want to look at is related to objects. So let's do console.log of, let's say, an empty object and set it equal to another empty object. And when we log this out, it's going to be false. And why is this false? Well, when we compare objects with each other, and this will even be false with loose equality. So when we compare these objects to each other, what we are comparing is, are they the same object? We aren't comparing the values inside of the objects. So in this case, these objects have nothing inside of them, but they're different objects. However, if I say const obj equals, and then save this object, and then we set these equal to each other, these are equal because they are the same object. They are both pointing to this object right here. These are even equal with the strict equality because they have the same type. They're both of type object, and they both are equal to this specific object. And the same thing is true of arrays. So arrays are just a type of object. So if we do array equals an empty array, and we set these equal to each other, it will be true. However, if we set this equal to some other empty array, this is going to be false because this array is different from this array, which is this one. They might have, so they cannot be equal to each other. Now, that's most of the rules related to strict equality and loose equality. But then the question is just, which one should we be using? And like most of the which one of these should I be using types of questions, the answer can be a bit ambiguous and it can be a bit of a it depends. But what I would say is 95% of the time I would be using the strict equality operator because of the fact that it just does what you expect. Do you expect the string 5 and the number 5 to be equal to each other? Probably not. You probably don't want that. And if you're checking these things against each other, you probably have a bit of a bug in your code that you should be working out to be writing cleaner. There's not many scenarios when we want to be comparing two values of different types and assuming that they are the same. So the vast majority of the time, I would use the strict equality. And the one exception that I might make is to use loose equality for checking against null and undefined at the same time, using that shorthand syntax of just checking if null is equal to your value, because that is checking for null and undefined. So that would be my recommendation. Strict equality 99% of the time, loose equality only when checking against null and undefined. If you want to do it that way, you can also just use strict equality 100% of the time, and that is perfectly valid as well. And with that, that's going to be the end of this video on equality and type coercion. I hope you enjoyed it, and I'll see you in the next one.